Let me start now. So yesterday we started with the unit number 3, integral calculus. Okay, 5 different subtopics are there: reduction formulae, gamma function, beta function, DOS rule, and error function. Then we started with the reduction formulas, right? What is the reduction formulae? Suppose we have an integral in of this form, integration from 0 to pi by 2 e raised to minus x sine raised to nx dx. Okay, so this n is here in. As the power of sine term will change, this in will change. For example, in minus 1 will be like this. All remaining terms will be as it is, only power of sine will be n minus 1. Okay, so our aim is to find the relation between in minus 1, in minus 2, and so on. And why we are finding this relation? So that we can solve this type of integrals. Okay. So consider an integral in. The relation between in minus 1 and so on is known as reduction formula. Okay. Then we started with the first example. The question was like this: in equal to integration from 0 to pi by 2 e raised to minus x sine raised to nx dx, and it is asked to find relation between in and in minus 2. And using that, we want to find I4. Okay. So here we want to use this integration by parts formula. This formula: integration of uv equal to u integration of v minus integration of u dash integration of v. Okay, and to use this formula, we have to decide what the u and v is. While deciding u and v, right, till we understood two different ways to decide the first function u, right? One, in 12th we understood that whenever we want to use this formula, integration by parts formula, we can use ILAT rule, ILAT rule, okay, to decide the u. Then to use the chain rule of integration by parts, okay, we want to select u such that derivative of the term become 0. And now this is the third rule. Okay, now how to choose u here such that we'll get from the in, we should get in minus 2. That is, in for this example, we want to choose u such that the power of sine raised to nx, power of the sin x term, should decrease. And it is possible if we differentiate this. Okay, so sine raised to nx is u, which we are going to differentiate. The remaining function is v, and no doubt, if we consider e raised to minus x as the v, then only it is possible to integrate. Integration of sine raised to nx is not possible. Okay, then we use the formula. We obtain this answer. The integral again contain cos x. Okay, here is the integral. The integral contain cos x. We want to remove this cos x. For that, we use the formula of integration of uv, again considering u as the trigonometric function and v as the exponential function. Then again we differentiated, and then we got in minus 2, and then we obtained the required relation. This is known as reduction formula of the given integral in. And then this reduction formula is used to find I4. So what we have done, we substituted n equal to 4 in the equation number 2. We got relation between I4 and I2. Okay. Then to find I2, again we substituted n equal to 2 in the equation number 2. We got a relation between I2 and I0. Okay. And to find I0, now we use the given integral. The given integral, in given integral we substituted n equal to 0 and we obtained I0, that is equal to 1. And then by back substitution, we started with the last equation, that is equation number 4. I2 equal to 2 by 5 I0. We obtain I2 equal to 2 by 5. Then to find I4, we use the equation number 3, that is 12 by 17 I2. 12 by 17 into 2 by 5, 24 by 85 is the required answer. Okay. This is the procedure to find the reduction formulas. We'll continue with the page number 7. Hope everyone is here. Yes, I think maximum people they have joined. Let me continue. Page number 7. We'll go through a few more examples of reduction formulas. Right, page number 7. Today is 18/6/21. Okay. We'll go through the next example on the reduction formula. Take out the notebook, start writing with me. So today we'll try to solve at least 2 more examples. So it is like this. If in equal to integration from 0 to pi by 4 sec raised to n theta d theta. Okay. Find relation between in and in minus 2. Hence, find I6. Use it to find I6. Okay, so we'll start like this. Given in equal to integration from 0 to pi by 4 sec raised to n theta d theta. Yes, different options are right. First option, what we can do, we can consider like this: 0 to pi by 4 sec raised to n theta into 1 d theta. We'll consider this as v, this as u, and then using this uv formula. Hope everyone remember the uv formula. Integration of u and then multiplication. See what we'll get. U as it is, sec raised to n theta as it is. Don't have to write, just understand. Integration of the v, that is integration of 1, that is theta. Then we have to substitute the limits. Limits are 0 to pi by 4. Okay. Next is minus sign. 0 to pi by 4, right? U dash, it should be u dash, derivative of sec raised to n sec raised to n theta into, what is derivative of sec n minus 1, sorry. What is derivative of sec theta? Sec theta tan theta into integration of 1, that is theta d theta. But see, in this way, see what we are getting. See this term. Ultimately, what our aim is, we have in and we want to find in minus 2, na? That is, we want this type of term, 0 to pi by 4 and sec raised to n minus 2 theta d theta. So integral should contain sec term only with a different power of the sec term. But here we are getting this, we don't have any problem with the tan theta term. Tan theta can be converted into sec theta if you have tan square, right? 1 plus tan square theta equal to sec square theta, that we know. So we don't have any problem with the trigonometric term. We have problem with this theta. This is a problematic term. So considering v as 1 will not give the required answer. Hope this is clear to everyone. If you consider u and v in this way, it is not possible to obtain the required answer. Is it clear? Why? Due to this theta term, right? Problem is due to this theta term, right? If you integrate once again, the theta will become theta square by 2. But the integral is free from the theta. Integral contains sec theta term. ये समझ में आ रहा है सबको? आ रहा है सबको समझ में? तो ऐसे हम नहीं करेंगे. हाँ?
Sir, explain one more time.
हाँ, see, what is logical option? Usually what we do, if we don't have any other term, if we have single term only, we consider 1 as v, which is readily integrable, easily integrable. Na? So I consider v equal to 1 and I consider sec raised to n theta as u. Then here I use the uv formula. Clear? Okay. This is the first term. Right? Here limits are there, so we don't have to bother about this term. Go to the second term. Second term is integral term, and the integration contain trigonometric term. All these are trigonometric terms. Again, we don't have any problem about the trigonometric term since tan theta can be converted into sec theta, therefore. Okay. But we have theta over here, and theta cannot be converted into sec theta. But see the in minus 2. Does it contain theta term only? It contains theta, but it is sec theta. We don't have separate theta term. Right now? And here we have separate theta term. Therefore, if we proceed in this way, it is not possible to find the reduction formula. Right? It is not possible to find the relation between in and in minus 1. In minus 2, sorry. एक मिनट थोड़ा सा इसको ज्वाइन करता हूँ. हाँ चलो हो गया. हाँ तो अभी मैं दूसरा ऑप्शन ढूंढता हूँ. अच्छा बताओ, कोई बता सकता है और क्या ऑप्शन लिख सकते हैं हम?
Sir, directly integrating sec and sec raised to power n theta.
नहीं कर सकते ना, कैसे करेंगे? It is not directly
Then,
integral, therefore we have
sir,
to. हाँ,
we can write 1 as sec square theta minus tan square theta.
I'll go to that step. Before that, let me go through this step. One more option. I'll consider like this: sec raised to n minus 1 theta and sec theta. Now we'll see what will happen. Your answer is correct, but everyone should understand it. Therefore, let me take different options and then we'll see what will happen. So I'll use the UV formula. I'm considering sec raised to n minus 1 theta as u and sec theta as v. Now see what will happen. U as it is, sec raised to n minus 1 theta as it is, into integration of sec theta. We can integrate sec theta. What is the integration? Log of sec theta plus tan theta. Right? This is the first term. And then we will substitute the limit. We don't have to bother about the first term. We'll get some answer from the first term. Now concentrate on the second term. 0 to pi by 4. Then u dash. Okay, so derivative is n minus 1 sec raised to n minus 2 theta and then sec theta tan theta. Till we don't have any problem. Into integration of the sec theta. But what is the integration of sec theta? Log of sec theta plus tan theta. D theta. And we have problem due to this logarithmic term. Now don't say it is trigonometric term, right? Now it is logarithmic term. But our in as well as in minus 1, these two terms, in and in minus 2, both of them contain sec theta only. They are free from the logarithmic term. But we are getting logarithmic term here. Right? So problem is due to this logarithmic term. So in this way also it is not possible to get the required answer. Right? So we cannot use this type of u and v also. समझते श्रवण ये समझ में आ रहा है सबको? तो मुझे और कुछ ऑप्शन ढूंढना है. So I want to choose correct u and v so that after integrating I should get the sec term only. Right? I should not get logarithmic term. I should not get theta term. I should not get exponential term. That is the condition. Okay. So let me change the page and let me consider u and v correctly now. Option 1 and option 2 will not work. I think you might have understood it. You don't have to write anything from this part. Just understand. Okay. Let me go through the next page and there I will write the correct way of deciding u and v, which will give the required answer. Okay. So just 1 minute only. Let me change the page. So we have like this, in equal to, now you can start writing from here, 0 to pi by 4. And now I'll consider someone has given answer to me before sometime, sec raised to n theta and then sec square theta d theta. Can we integrate sec square theta? What is integration of sec square theta? Tan theta, na? Right? So yes, I'll consider this as u and I'll consider this as v. And I'll use this formula using, now you can write with me. And those who understood can solve yourself. U dash integration of v. So u as it is. So sec raised to n minus 2 theta as it is into integration of v, integration of sec theta. What is integration of sec theta? Tan theta. Right? This is the first term. Limits are 0 to pi by 4. Minus of integration from 0 to pi by 4. U dash derivative of sec raised to n minus 2. n minus 2.
Sir, वो sec n minus 1 होगा ना फर्स्ट टर्म?
Which term?
वो sec n minus 2 जो लिखा है आपने वो n minus 1 होगा ना फर्स्ट वाला?
नहीं ना, n minus 2 आएगा ना.
sec n
कौन सा बोल रहे हैं आप? ये बोल रहे हैं जो कर्ली ब्रैकेट में लिखा है दिस टर्म?
हाँ सर वही.
नहीं, as it is ना, u as it is. So sec raised to n minus 2 theta as it is. Power, if you add the powers na, n minus 2 plus 2 will be n na.
Yes sir, yes sir.
Right, therefore. Okay. So n minus 2, then sec raised to n minus 3 theta, I am differentiating. Derivative of sec theta, tan theta. This is just derivative only, into integration of v. So what is integration of sec square theta? Tan theta. Right? And then d theta. Let me simplify this. Now let me substitute the upper limit. What is sec of pi by 4? Sec of pi by 4. Root 2, na? Hope everyone remember this. And what about tan of pi by 4? Tan 45 degree? 1. Okay. So I'll use these values. Upper limit is root 2 raised to n minus 2 into tan pi by 4 is 1. So no need to write it. Minus sec of 0 is 0. Sec 0 is 1, but tan 0 is 0. Okay, so this is 0 since tan 0 equal to 0, therefore minus of. Now I am writing the integral terms. So n minus 2 I am taking outside, then integration from 0 to pi by 4 sec raised to, this is n minus 3 and this is sec raised to 1, so sec raised to n minus 2 theta into tan theta, tan square theta, and then d theta. Hope you might have understood it. So root 2 raised to n minus 2 minus of n minus 2 integration from 0 to pi by 4 sec raised to n minus 2 theta. Okay, then what is tan square theta? Sec square theta minus 1 d theta. Simplify this. Root 2 is 2 raised to half, right? Raised to n minus 2. I'll simplify that in next step. N minus 2 integration from 0 to pi by 4 sec raised to n theta minus sec raised to n minus 2 theta d theta. Okay, again simplify this. So 2 raised to n minus 2 divided by 2 minus of n minus 2 integrals are 0 to pi by 4 sec raised to n theta d theta minus minus plus n minus 2 0 to pi by 4 sec raised to n minus 2 theta d theta, and now we can write them in terms of in. So it is 2 raised to n minus 2 divided by 2 minus n minus 2. Yes, what this integral is, same as the given integral, right? Then n minus 2, what this integral is, I n minus 2. Hope everyone is getting all these steps. And what we are doing, we are writing it for the in. So on the left hand side we have in. Remember this. On left side we have in. Hope you might have written all the steps. Please write it. Be fast. चलो थोड़ा सा जल्दी, हाँ. We want to cover this topic in next this lecture and one more lecture. Only 3 lectures are there for this topic. Can I change the page? Okay. So now I'll take in to other side. So we have like this, page number 9. In plus n minus 2 in equal to 2 raised to n minus 2 divided by 2 plus n minus 2 in minus 2. So 1 plus n minus 2 in, no change. So it is n minus 1 in, no change, and therefore in equal to 2 raised to n minus 2 divided by 2 divided by n minus 1 plus n minus 2 divided by n minus 1 n minus 2. So the given integral should be written as equation number 1. If it is not written, please write it. Hope you might have understood this. Now write down. Return up to this step. I'll go to the next step. Write down. To find I6. So write down. Substituting n equal to 6 in 2. Substitute I6 equal to 2 raised to n minus 2, 6 minus 2, 4, 4 divided by 2, so 2, let me write it directly, divided by n minus 1, 5, plus n minus 2, 4, n minus 1, 5, and then I 4. Okay, so 4 by 5 plus 4 by 5, I 4 equation number 3. Substitute n equal to 4 again in equation number 2. So I4 equal to, why we are finding I4? Here we have I4 na, right? But I4 is not known to us for that. So n equal to 4. So again substitute n equal to 4 in equation number 2 here. 2 raised to 4 minus 2, 2, 2 by 2, 2, sorry 1. 2 raised to 1 divided by 3 plus 4 minus 2, 2 divided by 3, I2. So 2 by 3 plus 2 by 3, I2. Now we have to find I2, but equation number 1 implies in equal to integration from 0 to pi by 4 sin raised to n theta. You can find I2 also from the equation number 2. मैं क्या बोल रहा हूँ समझ में आ रहा है? और एक स्टेप आप यू कैन राइट लाइक दिस, सब्स्टिट्यूटिंग n इक्वल टू 2 इन इक्वेशन नंबर 2 और आप I2 इन टर्म्स ऑफ I0 फाइंड कर सकते हैं. क्या देख लीजिए आप. हाँ 0 आएगा ना फिर n इक्वल टू 2 माइनस 2, सो नहीं आएगा. सो बेटर डू इट इन दिस वे.
32 divided by 15.
Absolutely. Very good. It is always better to solve it yourself once you understand, na? Upper limit 10 by 4, lower limit is 0, 1. So I2 equal to 1. Now I'll substitute that in equation number 4. Hope you might have written up to this step. Finding value of I6. This type of examples are expected in the online exam, in CQ exam. चलो मैं आगे बढ़ता हूं. अभी क्या करना है? अभी I2 फाइंड किया है हमने. Substitute I2 in the equation number 4. Can I change the page? 2 by 3, 4 by 3. Two by 3 plus 2 by 3 I2, but I2 is 1. So 2 by 3 plus 2 by 3 into 1. So 2 by 3 plus 2 by 3, 4 by 3. Four by 5 plus 4 by 5 into I4. You can do it using calci also. Suresh, you are getting answer like this?
No sir. 32 divided by 15.
See whether I am making mistake anywhere or you might be
you're
making.
right is sir answer.
28 by 15 है सर.
28 by 15 आ रहा है.
Okay, great.
Yes, sir.
Sir, I will check again.
हाँ check करेगा. And all the steps are there. I have written on the screen. You can go through it. Okay. Let's go through one more example. Write down. Hope you might have written the answer. Hope everyone is here. थोड़ा सा हर एक को बोल्ड बनना है, शाय नहीं रहना है, यानी बोलना है. यदि आपको समझ में नहीं आ रहा है या कुछ भी है, you have to speak here. And everyone is online, तो बोलने में क्या प्रॉब्लम है? यहाँ पे कॉलेज में आओगे तो हो सकता है कि everyone will observe you whenever question will be asked to a particular student, and you may become shy. but online doesn't matter, no? So you can speak whatever you like, whatever you understand, whatever your doubts. It is better to speak. I have seen that only few students are there who used to speak. So I know that many of you have understood it, and many of you are there who are having the doubts, but usually they don't use to speak. So please make the required change. Start speaking. This is a good platform where you can start speaking, and once you will be here in second year, you can participate in extracurricular activities, and you can improve your daring and communication skill and all these things. Okay, start. If I n equal to integration from pi by 4 to pi by 2 quarter raised to n theta d theta, find relation between I n and I n minus 2. Also find I3. Given I n equal to pi by 4 to pi by 2 quarter raised to n theta d theta. Acha. So as we considered in previous example, if we consider like this 0 to pi by 4, sorry, pi by 2 it should be pi by 2 quarter raised to n theta into 1 d theta. Then the integration of 1 will be theta, but we don't want theta, right now? So we should not consider 1. Instead of that, suppose I consider cot theta. What is integration of cot theta? Log of sine theta. But again, we don't want log term, so better to consider cot square theta. Hope you might have understood, huh? Same
Yes,
as
sir.
the previous example. Same as the previous example, right? We can consider u as 1, but that will give theta. So avoid that. Okay. If we consider cot theta as the u, we'll get logarithmic term. We don't want logarithmic term. Therefore, better to consider cot square theta. So it is cot raised to n minus 2. Cot raised to n minus 2 theta into cot square theta. Cot square theta, can we integrate cot square theta? Yes, minus cosec theta. Integration of cot square theta known to us or not known to us?
Yes.
No, no.
Yes, sir. No.
Integration of cot square theta. No, we don't know. Yes or no? You forget the integration formulas.
And we have to change it to.
Correct. Absolutely. That is important. Okay, so let me go through the next page. Page number 11. Can I change the page? See, this is the change that that is expected. So we have I n equal to integration from pi by 4 to pi by 2 cot raised to n minus 2 theta into cot square is 1. Cot square is 1 plus cot square equal to cosec square theta. So cosec square theta minus 1, isn't it? Okay. Now we have two different terms like this. Pi by 4 to pi by 2 cot raised to n minus 2 theta cosec square theta d theta minus of pi by 4 to pi by 2 and cot raised to n minus 2 theta d theta. Can you write this in terms of I n? Can you write the second integral as I n minus 2? Yes, that is in fact I n minus 2, isn't it? Getting
Yes, sir.
everyone? Right. What about the first integral? What should be done for the first integral? Should we use UV formula for the first integral?
Yes, sir.
Is it required? Any other alternative is there? Somehow we want to remove the integral sign. Can we remove the integral sign by any other method? Can we use the substitution method to remove the to solve the integral? for the first integral, can we use any substitution so that we'll able to integrate it, or should we use the integration by parts formula? काय करायचं सांगा चला फास्ट सोपा आहे, इट्स व्हेरी सिंपल.
सर कॉट एन
Cos
मायनस 2 थिटा मधनं कॉट थिटा बाहेर घ्यायचं म्हणजे ते कॉट थिटा इंटू कॉट एन मायनस 3 थिटा येईल आणि कॉस स्क्वेअर थिटा कोसेक स्क्वेअर थिटा इज इक्वल्स टू टी टाकून त्याचा डिफरन्शिएट करून सबस्टिट्यूट.
Okay, okay, okay. Tell me what is derivative of cot theta? Derivative of cot theta. You forget everything.
लॉग ऑफ साइन थिटा.
cosecant square theta.
Array, don't tell integral formulas. Tell me derivative formulas. That is what. Okay. So late. No any other calculation is required. Just you decide the correct substitution. You will get the required answer. What is du? Minus cosec square theta, na?
Yes, sir.
Isn't it? And remember that whenever we use the substitution, what will change? Limits.
Limits.
Absolutely. See, limits will change in this way. Whose limits are known to us at this moment? Limits of theta are known to us. What are they? Pi by 4. I am writing it for the first integral only. Second integral is in minus 2. We don't have to bother about the second integral. Okay, our aim is to remove the first integral. Our aim is to solve the first integral, and for that we are using this substitution. So pi by 4, what is cot of pi by 4? 1. What is cot of pi by 2? 1 upon tan of pi by 2. Tan of pi by 2 is infinity. 1 upon infinity is absolutely 0. Okay, so see how the first integral will change. I'm writing the change over here. Okay, in equal to integration from pi by 4 to pi by 2, that will become 1 to 0, isn't it? Then cot raised to n minus theta, that will become u raised to n minus 2. Okay, then cosec square theta d theta, that is become
Minus
du. Absolutely. And then we have in minus 2. Okay, so take minus sign outside. If you want to change the order of limits, it is okay. If you want to keep as it is, no any problem. That will not make any problem. This is usual integration. Integrate it. So u raised to 1 is to be added. U raised to n minus 1 divided by n minus 1, isn't it? Limits of u are 1 and 0. Okay, so it is minus of upper limit 0, lower limit 1. So we have in equal to 1 upon n minus 1 minus in minus 2. In equal to 1 upon n minus 1 minus in minus 2. Hope you might have understood it. So nowhere we have used the integration by parts formula. Okay, so aim you should remember. What our aim is, somehow we should get in minus 2. This is the first aim. And second aim is somehow we should able to solve the integral. We may have to use integration by parts formula, or we may have to use substitution as it is used in this example. By hook or crook, we should be able to solve the integral. No doubt, by correct method, correct formulas, correct procedure. Clear? Okay, so see, in this way, though it may possible that in the whole engineering or in whole life, the reduction formulas may not be required anywhere. है ना? ये हो सकता है. Maximum cases में ऐसे ही होता है कि reduction formula की जरूरत ही नहीं पड़ती है लाइफ में, है ना? लेकिन यहाँ से हम लॉजिक डेवलप कर रहे हैं कि क्या करना है एग्जैक्टली. हाँ, तो whenever you want to solve any problem, I'm saying whether it is problem of mathematics, whether it is problem of your engineering, or whether it is real life problem. हो सकता है आपकी शादी के बाद रिलेशन अच्छे ना हो, है ना? कुछ भी हो सकता है, झगड़े हो, आपके फैमिली के साथ झगड़े हो, वाइफ के साथ झगड़े हो, हस्बैंड के साथ झगड़े हो. तो क्या करना है, ये लॉजिक यूज करना है. क्या लॉजिक यूज करना है? पहले देखना है कि हमारे पास क्या है, राइट ना? तो व्हाट वी हैव द इंटीग्रल. Okay, again what we have different formulas of the integration by parts का formula है, substitution method का formula है, और integration का काफी सारे formula है. We can integrate cosec square theta. We don't know how to integrate cot square theta, but we converted that into cosec square theta. उसको simplify किया, है ना. ये हमारे पास है. और कहाँ पे पहुंचना है? We want relation between in and in minus 2. So हमारे पास क्या है और कहाँ पे पहुंचना है? If this is clear, बीच के step difficult नहीं होते. हाँ, लेकिन यदि ये क्लियर नहीं है कि हमारे पास क्या है और कहां पे पहुंचना है, then it is very difficult, then life will be very difficult, then solving problem will be very difficult. Okay, this is what we are studying in the mathematics. Okay, तो कई बार ये आता है कि आपने व्हाट्सएप पे मैसेज भी देखे होंगे, ये sin थीटा और cos थीटा कहीं पे पढ़ा ही नहीं लाइफ में. We started it studying maybe in 7th 8th standard and till we are not used it anywhere in the life. ऐसा नहीं है, it is used at one or other place unknowingly, या एटलीस्ट मैं ये कहूंगा कि उसका जो मैथमेटिकल जो पार्ट है, मैथमेटिकल लॉजिक हमने जो डेवलप किया, दैट वी आर यूजिंग एट इन आवर डेली लाइफ आल्सो. ओके, लेट मी कंटिन्यू विद द एग्जांपल. राइट दिस एज इक्वेशन नंबर. हाँ, यस.
1 minus infinity.
हाँ,
1 minus infinity.
n minus
1 infinity.
n minus infinity.
1 माइनस बोल रहे हैं.
1 minus infinity. आप ही बताओ 1 minus infinity क्या आएगा. अब आप लॉजिक यूज करना है ना. फॉर एग्जांपल 1 minus मैंने 1000 लिया, है ना, तो क्या आएगा? -999 आएगा. राइट. 1 minus 1 करोड़ लिया मैंने. हाँ, कितने चाहिए, जितने चाहिए उतने जीरो लिख दीजिए. कितना आएगा? -999. एक कम करके नंबर आएंगे, है ना. तो लॉजिकली क्या आएगा बताओ? 1 minus infinity, माइनस इन्फिनिटी आएगा.
माइनस इन्फिनिटी.
हाँ, वेरी लॉजिकल. ओके, यस, लेट मी कंटिन्यू. सो आई एन, थोड़ा सा बाद में करते हैं, इसको सॉल्व करते हैं. आई नो दोज एग्जांपल्स आर मोर इंपॉर्टेंट, बट ड्यू टू द टाइम क्रंच, डोंट हैव दैट मच टाइम. दिस इज वेयर वी रीच नाउ. ओके, in n minus 2. Right now, next to find I3. Now our aim is to find I3. Start करते हैं. Substitute n equal to 2 in equation number 2. So n equal to 3, sorry. I3 equal to 1 upon 3. So minus 2 minus I1. 1 upon 2 minus I1. But what is in pi by 4 to pi by 2? क्या था एग्जाम्पल? Quat raised to n theta. Quat raised to n theta d theta. So substitute n equal to 1. So I1 equal to pi by 4 to pi by 2 quat theta d theta. So integration is log of, what is integration of cot theta? Cot is cos by sin. So sin theta,
log of sin.
absolutely. Limits are pi by 4 to pi by 2. Upper limit is pi by 2. So log of sin of pi by 2. Sin of pi by 2 is 1 minus log of sin of pi by 4. 1 upon root 2. Okay, log 1 is 0 minus. So 0 minus, but what is log a by b? Log 1 minus log of root 2. Okay, so log of root 2. You can keep as it is or you can write it as a half. I'll write it. Log root 2 means 2 raised to half.
0.
That is, no, keep in this way. Keep the fractions as it is. This is I1. From 3, what is I3? Half minus I1. Half minus half log 2. So I3 equal to integration from pi by 4 to pi by 2. थोड़ा सा स्पेस कम है यहाँ पे. So cot raised to 3 theta d theta, that is equal to half 1 minus log 2. This is the answer.
Numerically it is 0.65.
Acha. But usually the numerical values are not required. Usually they are not required. So if this example is asked in any exam, maybe GATE exam, maybe GRE exam, maybe our exam, then it will be in this form only. Page number 12. Yes, let me go through the next part. How much time we have till? Around 15 minutes are there, I
15
think.
minutes.
Absolutely no
Yes,
problem.
sir.
Yes, okay. So find. Next example. Let me change the page. Hope you might have completed fast. Complete it. Sure.
Yes.
जल्दी complete करो आप. Okay. एक एग्जांपल और एक देखते हैं. छोटा एग्जांपल है. Simple example. Then on next page, find reduction formula for. So I have to change the page. And find reduction formula for, right? In equal to integration from 0 to pi by 2 sin raised to nx dx. चलो सॉल्व करते हैं इसको. in equal to 0 to pi by 2 sin raised to nx dx 1. अच्छा, इसको कैसे कर सकते हैं? Like this, 0 to pi by 2. So selecting u and v is very important. Sin raised to n minus 1 x into sin x dx. This is the u. Sorry, this should be v. This should be u. V should be integrable, u should be differentiable. Derivative, finding derivatives is usually not difficult. U as it is, integration of v minus u dash integration of v. So in equal to u as it is, sin raised to n minus 1 x into integration of v, integration of sin x minus of cos x, limits 0 to pi by 2 minus of integration from 0 to pi by 2 u dash. So n minus 1 sin raised to n minus 2x in derivative of sin x is cos x into again integration of v na. So this integration of v means integration of sin x minus cos x. Simplify this. Upper limit cos pi by 2
Sir?
0. Yes.
तर त्या आतल्या इंटिग्रेशनला 0 to pi by 2 नाही लागत का?
No. We have to multiply all these na, and then integration is there. After this integration, we have to substitute the limits. Actual procedure is na, first we have to solve the whole integral, and then we have to substitute the limit. Actual procedure. Got it? Therefore, we cannot substitute the limits here inside. But here it is okay. Since this term will not change now, na? Already integrated, na? Therefore.
Yes, sir.
Okay. Minus of lower limit is 0, sin of 0 is 0. Therefore, lower limit is 0. Mention this so that you'll understand why it is 0. Minus sign. Minus minus it will be plus. Constant I am writing outside n minus 1. Now we have to now we have 0 to pi by 2 sin raised to n minus 2 x into cos square x. But we want everything in terms of sign. Therefore, it is n minus 1. First term becomes 0. Integral, that is second term. We are working on that. Cos square x is 1 minus sin square x. Okay, dx. So it is n minus 1. Let me write the two integrals, 0 to pi by 2 sin raised to n minus 2x dx minus of n minus 1 0 to pi by 2 sine raised to nx dx. Right up to this step, and both the integrals now can be written in terms of in minus 2 and in respectively. That we'll do in the next step on the next page. And at the end of this example, we are developing a very important reduction formula. And the next 2-3 examples, they are for homework. If you have time, you can go through them. At least you have to remember the formulas. We are going to write the 4 formulas and then we'll stop for today. The 4 formulas that we'll use in the type number 2 to solve few examples. Okay. Hope you might have written it. Can I go to the next page? Page number 14. So we have like this. In equal to n minus 1 in minus 2 minus n minus 1 in. Okay. So I'll take in to other side. And on right side we have n minus 1 in minus 2. Let me add them. 1 plus n minus 1 in. So n, let me write it directly. This may be asked in the MCQ. So you have to remember the formula, okay? Don't remember the whole procedure. Just remember the formula. That will be more than sufficient. A remark. Okay. So I'm doing like this. Substituting n equal to n minus 2 in 2. Yes, tell me what will be in minus 2.
N minus 3.
Absolutely. N minus 3 divided by n minus 2 and then n minus 4, isn't it? Now tell me what will be n minus 4.
N minus 5.
Absolutely. In equation number 2, substitute n equal to n minus 2. N minus 4. N minus 4, n minus 5, then n minus 4 previous number, and then in minus
Minus 6.
and now so on. Okay. So see, now I have to write in. I am starting from equation number 2. Understand? Concentrate. So I'll mention that from equation 2, what is in? That is equal to n minus 1. Understand? In minus 2. But what is in minus 2? Here it is. Okay. So n minus 1 divided by n as it is, and in is n minus 3 divided by n minus 2, and then in minus 4. But I have in minus 4. Here it is. Okay. Substitute that. So n minus 1 divided by n minus 3 divided by n minus 2, and what the in 4 is n minus 5 divided by n minus 4, and then n minus 6. Hope you might have understood. Okay, so see, we are doing like this. We are starting from the denominator. See the first term. See the first fraction. Here it is. Okay, n denominator n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 6 here. Getting? So if I write next few terms, it will be like this. N, now understand, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5. Next term, n minus 6, n minus 7, n minus 8, n minus 9, n minus 10, n minus 11, and then yes, n minus 12, right? N minus 3, n minus 4, na? Again we have to subtract 1. Hey, samajhte sarvana? Getting everyone? This is the reduction formula for the sine term. But see now, again start with the equation number 2. There is n in and in minus 2, difference of 2. Therefore, there will be two different formulas for the even number and odd number. What does it mean? For example, suppose I'm using this formula, above formula. Suppose I have I10. So how to start it? See, In, and then I'm starting from n in denominator. I10, so I have to start like this. 10, go on subtracting 1. 9, 8, 7, 6, 5, 4, 3, 2, 1, I not. Isn't it? Okay. Say I want to start with the I13. Yes. How I have to start? 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I1. Getting everyone? Namaste, Sravana. Okay.
Yes, sir.
So let me generalize these things. For n even number, right? Last term is I naught. For n odd number, okay, last term is I1. So now we'll find I naught and I1, and then we'll generalize the formulas. There should not be any confusion. If till there is confusion, keep patience for some time, and at the end I'll tell you what you have to remember. Okay, give me some time. So I'll go to the next page, page number 14. Just I'll revise everything once again, so that in short I will revise. The required things only I'll revise. So right now we are here, 15. We started with this example. Our aim was to find reduction formula for in equal to 0 to pi by 2 sine raised to nx dx, and we reached here. We obtained this formula in equal to, if you remember these things, that will be more than sufficient. n minus 1, n minus 2, n minus 3, n minus 4, n minus 4, n minus 5, and so on. Sometime we get I naught whenever n is even, and whenever n odd, same procedure only, n minus 1, n minus 2, n minus 3, and so on. But we get I1 at the end, n odd. Okay, now we want to find I naught and I1. Okay, so in one, put n equal to 0. So I naught, 0 to pi by 2. Sine raised to 0, x dx. Sine raised to 0 is 1. So 0 to pi by 2 dx. Right? So x, 0 to pi by 2. Pi by 2 minus 0. So I naught equal to pi by 2. Hope everyone is getting this. Okay. In 1, put n equal to 1 and see what we are getting. So I1. Now we'll able to obtain I1. So 0 to pi by 2. Sine raised to 1. So sine x dx. What is the integration? Minus of cos x, 0 to pi by 2. So minus of cos pi by 2, 0. Minus minus plus, cos of 0 is 1. So we have 1. Getting? So let me combine these three things. 1, 2, 3, 4. And now I am writing the formula for integration of 0 to pi by 2. Very important formula. Sine raised to nx dx. And the corresponding formula is n, the first few steps are same, n minus 2, concentrate, n minus 3, n minus 4, n minus 5, and so on. If n is odd and if n is even, we have two different formulas. If n is odd, here it is I1, and what the I1 is 1. So till we get like this, hope you remember, 2 by 3 and then 1 for n odd. You can refer the previous page. Then for n even, we have like this, n minus 1, n minus 2, n minus 3, same procedure, n minus 4, n minus 5, but we end with the ratio 1 by 2, and then absolutely, n by, here it is, into I naught. But what the I naught is? Pi by 2. Very important formula. We have to remember this formula. If you have not understood how the formula is developed,
Sir, page 9.
एक minute. Okay. If you don't remember how the formula is obtained, actually it is not okay, but time being it is okay. At least you should remember the formula. Very important to remember two things. One, this formula, and second, here. For this formula, in equal to n minus 1 divided by n I n minus 2. ये दो चीजें आपको याद रखनी है. ठीक है, और ये यहाँ से आप याद रख सकते हैं पहले टर्म से, है ना? n minus 1 divided by n I n minus 2. Clear? Have you understood all these things? Hope you might have.
Yes, sir.
चलो 2
Hello,
मिनट में
sir.
अटेंड. हाँ बोलो. यस श्रेयस फास्ट.
पेज तिथं π/2 चं बाजू 1/2 कसं आलं? ऑड इवन ला आणि ऑड ला 2/3 कसं आलं?
एक काम कर ना, सोपं काम कर. यू टेक एनी ऑड नंबर 11 घे. काय होते बघ. स्टार्ट फ्रॉम डिनॉमिनेटर. ओके. आय डोंट हॅव स्पेस ओव्हर हियर. चल लिहितो. पेज चेंज करतो आणि लिहितो. ठीक आहे. 0 to π/2 काय 11 घेऊ आपण. 11 थीटा d थीटा. सो 11 10 9 8 7 6 5 4 3 2 1. That's it for n odd. Actually this is I1 येतं, but I1 is 1. We obtain it. Therefore writing 1 is sufficient. So 0 to π/2 say sin raised to 6 theta d theta. So it is 6 5 4 3 2 1. 1 आहे म्हणजे इथं I0, but I0 is we obtained before some time. I0 is π/2, so it is π/2 and even. Clear?
Thank you.
Okay. Attendance. A division, roll number 1. First A division and then afterwards B division. थोड़ा सा fast, so that you will be free in time. 1. Roll number 1. 2.
Present, sir.
3.
Present, sir.
4.
Present, sir.
5.
Present, sir.
6.
Present, sir.
7. Absent. 8.
Present, sir.
9.
Present, sir.
10.
Present, sir. 10.
11.
Present, sir.
12.
Present, sir.
13.
Yes, sir.
14.
Present, sir.